Hi, I'm Mr. Franklin, and this is page 7, Properties of Matter worksheet. I'm going to talk through the key real quick. There are a couple of things that if you watch the video notes, you should be pretty good to go on, but there are probably some things that lack context because we haven't done one of the labs that's associated with some of these questions. So what are the three most common phases of matter on Earth? Solid, liquid, gas. Those are pretty much anything outside of those three phases is going to be man-made or man-manipulated on the Earth. The only exception that we can view from the Earth is our sun, which is made out of the fourth state of matter called the plasma. There are more phases of matter than that. One of my favorites is the Bose-Einstein condensate, which is when temperatures reach absolute zero. We get a new state of matter. So you can check that out if you want to. But solid, liquid, gas, those are what we experience daily. Number 2, what are some ways you can describe the appearance of a substance? So these are just some. There are more, of course. This is getting into the realm of what kind of measurement. This is all the way back from Unit 1. We had quantitative and qualitative. So we're describing the appearance, we're describing the quality of something. Generally, it's also in comparison to something else. So to talk about something as dull or shiny, you have to have something to compare it against. Because something that might seem shiny may seem less shiny if there's something that's shinier. That's not confusing. So which talks about number 3. Hardness is a comparison scale. What does this mean? So this means that a harder substance can scratch a softer substance. Diamonds are the hardest substance. But what does that actually mean? Well, what that means is this hardness is based on the hardness of a diamond. So the hardness scale is based on the hardness of another substance. So it's comparing, and we actually give this a numerical value, but those numbers represent a relationship to another thing. Another example of this is when we talked about temperature scales. The temperature scales that we use of Fahrenheit or Celsius, both are comparison scales. What does that mean? That means that both of those scales were created based on the freezing and boiling point of water. If you read 0 degrees Celsius, water freezes. That's just a number given to the state at which water freezes. So if we say something else, if we measured a piece of metal and we measured that temperature at 0 Celsius, all we're doing is comparing that to the temperature at which water freezes. Okay? That's one reason why scientists came up with the Kelvin scale, because it is not a comparison scale. But Kelvin is based on the kinetic energy of the particles in a substance. So it's more qualitative. Whereas even though this is a number, and we use it in our math all the time, especially in chemistry, it's still a reference to the point at which water freezes. And you can Google videos and understand how thermometers were created, and you can get a better understanding of that. Okay. But bottom line is we are comparing one substance to another, the quality, based on a standard that we have picked that's based on that substance's quality. Okay, number 4, describe what it means to be squashed and give an example of an object that can be squashed. Okay, so here's the book definition. The ability of a structured material to occupy a smaller volume. So if you take like a stress ball and you squeeze it down, you're making its volume that it occupies much smaller, but it's still under pressure because you're having to squeeze it down. Okay, so a sponge, like if you wash dishes and you use a sponge, that would be squashable. Okay, That's what squashed would be. Why is this important? If you ever get back into a physics class and they talk about impulse and momentum, the squashiness of a substance actually changes how it interacts with other substances when they collide. What are the units for density? So density is a favorite thing in chemistry to talk about and physical sciences because it is a way of talking about a piece of matter using both the constituent definition pieces of matter. So matter often is anything that has mass and takes up space. That's the definition a lot of people use. Well, density has mass and volume is what we call taking up space. So density, this is the Greek letter rho. Looks like a squiggly P, but it's actually the Greek letter rho. And mass divided by volume is density. And our units for mass is kilograms per meter cubed or grams per centimeter cubed. So for example, water's density is 1 gram per centimeter cubed. And then ice has a lighter density, which is why it floats on water. Okay, if two objects have different mass, does the object with more mass have a greater density? Yes or no? Explain. If we made all these values equal 1, so if the density equals 1, and the mass equals 1, and the volume equals 1, is that math true? 1 divided by 1 equals 1. That's true, right? If I took a second object, and its mass was 2, say 2 kilograms, but the volume was the same. So that's the key to this question. The same volume. Now what is its density? Its density is now 2. So if it has a bigger mass, guess what the density is going to be? Density is going to be greater. Anytime you're given one of these types of problems, this is what I do in my head as a double check. I mean, I'm pretty good with this kind of thing. So it doesn't take me but a second. But if especially on more complicated things like our gravity equation or Coulomb's law, sometimes I'll just plug in the ones and then plug in a multiple of the other number and see what comes out as the answer. Okay, number 7. Something soluble in water, what does that mean? Solubility means it can dissolve. It can mix uniformly within the water. That's a simple definition. In chemistry, you will learn a more sophisticated definition. Number 8, is food coloring soluble in vegetable oil? So this is one of those questions that was based on a lab we would do in class, and the answer is no. Number 9, brittleness is how easy it is to bend something. That is false. Brittleness is how easy it is to break something. So if you take a piece of metal, you can bend it, but you can't break it. Okay, so metal is not brittle, but a piece of glass, if you wouldn't want to do it with your hands because you would cut up your hands, but if you broke a piece of glass, it is much easier to break than a piece of metal. Brittleness is how easy it is to break into pieces. Okay, number 10, what is the relationship between structure and function? This is, if you think about it, this is such a deep question. Everything works the way it does generally because there is some structural component to it. Okay, so a glass holds water because it's shaped like this, and then you can fill it with water. It's the structure of that makes it work. The structure of water actually has a set structure. It looks like this. There's actually a specific angle that you might learn about in chemistry depending on how advanced you get. Because of that angle is caused because of the electric charges involved in the bonds, and so this end of the molecule winds up being partially, that's negative, partially negative, and this end winds up being partially positive. So this structure is caused by electric charge, but this structure also allows water to do this. So when you are measuring, you've probably learned this a long time ago, when you're measuring in a cylinder, water bends, right? And where do we measure? We measure at the bottom of the bendy part. It's called the meniscus. Okay, why does it even bend like this? Well, it's because of this. So the structure of this causes this. And so And because of this, we're actually allowed to use that in medical applications, things like that. Um, let's go think of another thing, Velcro. So you've hopefully have seen Velcro before. If you look at it carefully, you will see that a piece of Velcro, on one side, it has this little fuzzy part. Well, if you look closely, those are little bitty loops of nylon, okay? And the other part of the Velcro is generally a flap or a strap or something, and it has hooks. So this structure allows the Velcro to work the way it's supposed to work, okay? Structure often determines function. I mean, you could think about all kinds of things where the structure of that substance determines what it does. The structure of your DNA allows it to do certain things. It also keeps it from doing other things. So structure determines the function of an object. All right, well, that's all I've got. So I hope that maybe clarified some things. If you have any questions, please email me. Thank you. Bye.